Hello all. Do ping me hi or hello so that I'll just get a notification that it's all good and started. Okay, I got a ping. I can able to see that this isn't. Uh, it's live. Welcome to day 5 of the session. So in this session, I want to discuss. I want to give a different perspective of Kubernetes. So the very basic question will go back, right? Day 0, you can say, what is Kubernetes, right? So the agenda, looks like something like that. What is Kubernetes? What is your containers? And we'll also slowly touch base on volumes, and then we will touch base on config maps, and then we'll see a small demo of a config maps. So but today's session is very important. We are going to see Kubernetes in a different angle, a complete different perspective, right? So let me start with that. So you can see Kubernetes, you can imagine Kubernetes something like this. So there is a huge bulk, something is there, some server, some sort of backend machine you can call, right? It's a complicated machine. That's why I drawn some 3D cube or something. It's a complicated piece of thing. Before that, you have something called REST API server, kubectl, API server, what we call in Kubernetes, and with you are going to interact using kubectl command, which is nothing but a very simple REST client. Okay, this is what the Kubernetes is. So you are allowed to only interact using API server. So we'll dig upon what is this API server and how it works, right? Which will clarify and make your assumption simplify. Let's go back and try to understand what is API, what is a REST API, very basic definition. So for that, I drawn some image for you to understand. Let's take this very basic example of a school. Okay, so you take a school, like assume that school is a big object, or right, it's a logical object, right? Basically a school is a huge environment or something, or let's say it's an object is right anything which have a physical existence, we call it as an object, right? So in that school, what you find it, you find somewhere parents are also involved, students are also involved, and teaching staff, non-teaching staffs, and they teach these subjects: math, science, English, history. Here you can see that school is a physical entity which actually exists physically, right? Parents are physical, students are physical, right? Teaching staffs, non-teaching staffs, but these subjects are logical entities, basically logical entities or object. So let's call it an object, right? So everything is an object in this world, right? The whole earth itself is an object. In that, you have logical political map as, right, India as an object, and then you have US, right? In within India we have Karnataka, Maharashtra, and within Karnataka we have Bangalore. So we have something called as object within an object, and there are something called of aggregation also, right? Some inheritance concepts also. For example, here you can see subjects, then you will have a maths, English, science, and the best example is car, right? Car is a parent object, or parent class. Then you have Maruti car, Esteem car, right? All these kinds of inheritance. Okay, you may be wondering why I'm talking about all these, right? So I'll just conclude why it is important, right? So let's say this is your school, and let's say, right, this is your completely entity defines a school, and I want to design an API for it, right? How I'm going to design, we'll see from that perspective. So that is where I put it. Okay, if I take this parent and see it, then parent will look like something like this, right? We have parent 1, parent 2, like this we have hundreds or thousands of parents involved in a school, right? Each parents are a different object basically, right? They have each, right, they have their individuality, they have their tracking number, and each we call them as an attributes basically, right? Parent, then parent will have their name, first name, last name, their mobile number, their number of kids they have, and their kids name, and their kids grade, like this, like these we call it as an attributes or a properties, right? So each object, I mean these are the common attributes which are applicable to this, but each one of them have a different values. For example, parent 1 will have a different name and parent 2 will have a different name, right? So usually this kind of stuff, right, how we model in any software industry or anything, right? Any software modeling, we do something like this. Basically your database entities, right, everything you do it. Okay, now coming back to what is API server. Now on these entities I want to do some operations, right? What operations you can do? Basically you can add a new parent. I mean, let's say, right, I have a new parent admitted, then what I'll do is I'll create a new parent here, right? This is basically create, and suppose somebody is leaving this, suppose that P4 is leaving, then I can delete this parent, right, because he is leaving the school, or let's say, or we can modify the parent. For example, their mobile number changed, I'll just do the update. Their kids grade change from 4th standard to 5th standard, I'll do the updates. These we call it as an update, and then we can get the details also. The API also does the same thing. The API does very basic 4 operations, what we call it as a CRUD, C-R-U-D, right? So create, read, update, and delete. So create, I just told you, right? I mean, if you want to create an parents, you create it, you read whatever those parents are there, and you update and delete. Now the question is on what, right? So I just in my example I shown you about a school, all these things are valid, but in Kubernetes how it is, right? So in Kubernetes we call them as a resource or anything. Okay, so we call it as a resource. In API world the same entities are called as resources basically, right? So we do REST API allows us to do all four operations on resources. Okay, so now coming back, what are these resources, right? So okay, sorry, okay, here. So in Kubernetes, or what are the different resources is, these are the some of the example of the resources. For example, pods, you can create the pod, update the pod, read the pod, and delete the pod. Similarly, volumes, we are going to see what is the volumes, and we have config maps, we have networks, we have nodes, we have namespace. So anything in Kubernetes, they are object, and you can perform these operations: create, update, read, and delete, right? For example, when I say, right, let me go here and say, right, kubectl get pods. So you know that pod is an object, right? Basically pods are an object. It basically sends a request of getting all the objects here, right? You can see all these as object, they are listed here. Similarly, namespace, right? Get namespace, you can see that these are the 4 namespace what I have. So similarly, you can do lot of operations. Any Kubernetes, right? What you have to take away or imagine in next ongoing sessions is, right? So Kubernetes is nothing but an API server which allows you to perform basic 4 operations, right? What are those basic 4 operations? Read, update, delete, and create on any of the resources, right? Any of the resources in Kubernetes. Now comes what are the different resources in Kubernetes, right? So if you see my previous videos, there I have given you, right, there are different kind of resource. In storage we have difference, in security we have different resources. Like this we have different kind of resources everywhere. So we use those resources here, right? So we use those resources and we create these operations on that. And sometimes, like, some people may question, right, it's not only four operations, some things are linked. For example, pods and config maps are linked, pods and volumes are linked. How those operations are performed? Those operations are basically, there are special commands which, like, exactly, like, does the linking, or right, or like, mapping of these two resources. Those we are going to see it, and they are, like, very basic things, you can easily learn that. But at this point, like, you just have the view of this much, right? So let's move to, this is what my Kubernetes view is. At end of this day's lecture, I want you to, like, imagine Kubernetes something as a box with lot of objects, right? Lot of objects, and this API server allows you to create and delete those objects, right? So at a bigger picture, you can also imagine something like this. So you have a big compute engine means basically CPU. You ask any number of CPU. Pods means what? It's a basic, very CPU, small CPU unit. You ask how many CPU you want, right? You have a API server which will tell, like, create these many CPU, it will create. And you tell, like, this much RAM I need, it will create. You tell, like, this much hard disk I need, you can create. It's right, where it will, like, provide you how many servers, whatever servers you want, you will get it, just like, all through commands, whatever the kubectl commands you are learned all, like, during last 4 days. And there are more commands which you are going to learn it. Okay, now let's move to second part of it. What is containers, right? Okay, so now we know that it is a pod is basic unit of compute, basically basic unit of CPU with the small memory, what you are going to do. And what is a container? Okay, in one pod you can run multiple container, just remember this, right? So in one pod we can have the multiple containers running, right? So this is the diagram. So from day one we are, like, trying to see it. But there are different container technology which Docker supports, but Kubernetes supports different container technologies, but Docker is the famous one. So let's concentrate only on a Docker now. As of now, going forward, you can, like, explore the other container options also. So as we know, right, this is the VM and this is container. Container uses basically your host OS, and then you have one container engine, we call it as a Docker engine here, since we are using Docker, and then you run small apps here. So these are the container. So in pod, what happens is, pod contains a CPU, a RAM, and a container engine, multiple container engine, Docker engine. Basically it contains one Docker engine in pod, and from that Docker engine you can, like, spawn the multiple apps. Basically you can run multiple container images, right? So that is the statement. Pod can have multiple containers. Okay, now now we understood what is container. Let's see more. See, basically container, what it does is, here if you see that, right, here it is called as app 1, app A, app B. These are the applications, right? So to run any container, let's say we are taking example of Docker, so it needs image, it can't work, right? For example, if you want any application to run on Windows, you need one exe file, right? Just for example, if I say I want to run the paintbrush, then, like, I'll get something like this. Paint is a app is basically your exe file. So similarly, if you want to run this Word, then, like, you will have winword.exe or something, right? This is the file basically, where this exe is the file. So similarly, you are already aware that in your app also, in your mobile app also, you get these APK files where, right, whole everything is bundled in a one format that we call it as an APK format. So similarly, Docker runs its own image. So there is something called Docker repository, right? So which repository is basically where you will have multiple Docker images. For example, this is something called, okay, let me open this for you, hub.docker.com, right? If you click on this is the repository means from where you are going to have the where you have the multiple images, right? So here you can see that I am having multiple images basically. So see, these are the applications. MongoDB, okay, you get it here. You get MariaDB, you get Ubuntu. So if you remember, on day 1 or day 2 I was running Ubuntu on using kubectl, right? I mean, one command I given you using that. So what it used to do is, it used to fetch image from here. These are the images from where it is to take, and then it is to apply it. We are going to see, okay, probably I can quickly show you one. For example, this is the Nginx image what I was talking about, right? Nginx, this is the version. So this version and everything, so we are going to get it from one of the repository, image repository. You can find it somewhere here. You can search. Right. Yes, you can see that Nginx is here. So in this one, different versions are there. Then probably you can find the images like this. You can find all the softwares, right? Now it is a different world altogether. Earlier they used to give the exe files. Now we used to get these Docker image hosted on this Docker hub or something, if it is a Docker containers, right? So now, okay, now you may be you may be having the question, right? There is only centralized, only one repository or something. No, it is not like your Play Store, right? So this is a Docker store where you will get images, right, which are related to Dockers. So similarly, you can also host your own repositories. You can create your own repositories where you can host all your images. For example, I can build my own image and I can put it on my own repository. Like I can build a, like we in Azure we have something called Azure Container Registry, where you can build your own ACR, Azure Container Registry, and you can host all your images there. For example, each company have their own repositories and they will host all their libraries, their own libraries, third-party libraries, licensed images, all Docker images, they will host it. And in Kubernetes, we'll just pull all these images and apply it out. Hope I am clear about this. So I think we are almost 20 minutes. Let's try to touch two more topic, that is your volumes and config map, and then we'll jump to demo. So I'm going to touch very small thing here. So volumes, what is this volumes? Volumes is basically storage, as you know that, right? So okay, so let me open this. Okay, before that, you know that pod is very a small CPU unit, and it have CPU and it have memory. And we have in previous videos I also shown you how to set the CPU limit and set the RAM limit, that is your memory limit. Now the next question is, what about storage? What about hard disk? And you also know that pods can restart, right? You can restart, then what happens to your data? And as per this architecture, right, it don't have its own OS, or it don't have its own storage. It can share a storage with something, right? So what is the solution for this, right? For that, Kubernetes have something called as volumes. So volumes are something basically if you open this Kubernetes documentation, volumes are basically, it says that on disk files containers are ephemeral. Ephemeral means basically temporary, right? So all these pods are like, these are temporary, and similarly all your disk files and everything are like, temporary. So what how to do it now? If you remember, or if some of you have the networking background also, so you might be aware that there is something called storage, right? The storage, uh, for example, external hard disk, let's say very simple example is external hard disk. So you have a computer and then you attach a external hard disk. Like this you can attach lot of things, right? Earlier people used to attach that something called as SAN, storage area network, or NAS, network area of storage, right? Like this people used to have the different technologies. So Kubernetes allows us a following technologies, list of technologies. For example, AWS Elastic Block Store also you can put it, or Azure Disk. Basically, Azure Disk is your like Azure Blob Store, and then you can have Azure files if you are on Azure thing, or you can use a simple config map. Config maps are very simple. This is basically you hard code the things from your file and put it, right? And there are like different thing where you can attach for like there may be different names, like no need to scare, like get scared yourself like with these names or something. So what you have to think is all these are kind of like external plug-in device where you can plug to your pod and like get the data. Let's say like pod got restarted. When pod got restarted means it will get CPU also, right? I mean all the CPU is gone, memory is gone, whatever written everything is gone. Now it will create everything new. And similarly what happens is once it comes up, then it will go and attach to these volumes. Are like temporary disk. Volumes you can also think that it is a directory, basically a simple very empty directory or something, and then each directory have its own structure, right? And see here you can also have the Git repo. Basically your GitHub repo also you can attach your GitHub repo to these volumes, to these pods basically, right? So and with that, what is config map now, right? Config map is the way where you can send your local file to your pods. Let me show this diagram which explains something like this. Let's say this is your cluster, this is your pods, and these are your files. Like your blue is a file, your green is a file, and this gray is also a file. So here what you are doing is you are applying some command and you are copying these values within a cluster, creating the config map, and then attaching it to a pod, right? This is what happening here. Hope this is clear to you, and this we are going to do practically today, right? We are going to see how these things are done with the config maps. Config map is again an object, Kubernetes object, where you are going to create a config map and then attach it to particular pod. Okay, so with that I would like to move next. Okay, next is your demo time, so let's do that. Okay, so the first thing we have to do is you are already aware, minikube start, which I have already done it, so I'll just keep it, right? The next command for this is, I just listed few commands here so that it's a bit handy for me to execute. Okay, so I have created a two file here, right? I mean one is your config file. Okay, let's look at that. What is it? config.yaml. Okay, so here if you see our earlier one, right? I mean any pod you need to create, you have to create something called kind as deployment. Here you can see that we are creating kind as a config map. So this means that we are creating a new config map, right? So and you are going to give API server version, which is v1 Kubernetes, and then metadata you are going to give a name. Let's say example config map. So let's change it, example cf or my config map. Let me make it something like this, my config map, and let's say here I'll define my data. Now this data part, you can do any configuration. For example, if you are a developer or having the development background or something, you may be familiar, right? You need to give a lot of configuration data. For example, here database, which database to use, right? MongoDB or MySQL or something, right? Or you can have anything, let's say a simple game, then you can give a number of players, or life in a game, you will have around 5 life or 6 life, like that. You can also specify anything you want, you can specify here. Now once it is done, so let's I have to use this kubectl apply command and then file. So let me go back here, right? So before this, I wanted to make sure that this config.yaml is present here, right? So now let's apply it out. You can see that my config is created. Okay, so now let's see how I can see. I have did a create. Now I will do a get, basically, right? So I have to use the kubectl, then describe. I'm going to see config maps and then give my thing. You can see that this is applied, right? And remember that these config maps are applied at namespace level. They are not applied at a pod level. So pod can restart, but these configurations are going to stay. Just let me show you back again this diagram here. In this cluster, you are going to apply in a particular namespace, right? So this is completely different from your pod, right? So the pod can have multiple containers and each container can refer this file, right? Now you have done this, so you can also use this command to get kubectl get. This is bit more handy command, and show the original data, YAML data, whatever you supplied, right? Now the second part is, right, here I have shown that one is you have put this blue file here. That's what we did it now, data here. Now to link between this pod and this, what I have to do? Okay, so for that, you have to again write in a descriptive way. This is the magical thing, right, where you say that from environment config map ref, this is the tag you have to give, and in name you have to change the name, because I have changed the name now, right? For my name was not this. Let me copy the name from here. It is my config map, right? You can see that here the name is my config map. So I'll copy this name and I put it here, save it, or probably I can use this also, right, where you can save something like this, right? So this means that this I'm spinning the ngix image. I'm reading ngix image from Docker Hub or some container repo, and I am applying this config map, spinning up this pod, and I am applying this config to this. Let's do that. To do that, now I have created this. Let me go back and use the apply command, kubectl apply, and what is the name of this? Just a minute. I think here I have to put it. This is my local file, right? So ngx.yaml. So let me cross check that. Yes, ngx.yaml is there. So kubectl.apply ngx.yaml. Okay, you can see that this is configured now. So basically with this we achieved this much, right? So I think we are exactly at 30 minutes now, 31 minutes. I would like to stop here, and tomorrow we are going to see I'm going to start, sorry for the inconvenience, right? I was taking 1 week vacation in between. So but what I decided is from tomorrow onwards, I'll start this daily, without any break basically, right? Then only we'll be on time, and we learn something, rather sometime you miss also, right? And it is not a strict, we need to follow some schedule. So tomorrow at same time around 8:30, so we are going to see more on this config maps, right? We'll see more things. There are other things also, volumes, right? There are persistent volumes, there are snapshots, all those things are there, those, right? We are going to cover basically all the storage classes and everything. We are going to cover, and we are also going to see some example of that, right? So if you have any question, just put it in a chat. I'm happy to answer that. Or else you can also uh, uh, put the questions in our chat channel or in our WhatsApp channel, or you can reach me over phone or anything, so that we can I can clarify some doubts if you have any. Okay, with that, have a good day. Bye.